Section 1.3, Types of Data. In this course, we will encounter and work with all kinds of data. It is important to know how to classify the data because the type of data we are working with will provide some insight into the statistics that we can perform on that data. Throughout the course, we will need to consider whether we are talking about an entire population or talking about a sample of a larger population. This distinction is at the heart of the terms parameter and statistic. A parameter is a numerical measurement describing some characteristic of a population. A statistic is a numerical measurement describing some characteristic of a sample. Such a numerical measurement might be the average height of a population versus the average height of a smaller sample of the population. We can classify data into quantitative or qualitative. Quantitative data consists of numbers representing counts or measurements. For example, counting the number of people watching this lecture right now, or the heights of people in a room, would be quantitative. Qualitative data, also known as categorical or attribute data, consists of names or labels that are not numbers. For example, if I asked everyone in this course, "What is your favorite color?" the responses would be an example of qualitative data. When we are considering quantitative or numerical data, we can classify it as discrete or continuous. You have discrete data when the number of possible values you could get is finite, or what we call countable. The concept of countable can be difficult for some students when they first encounter it, so we will try to just get a general sense of what it means to be countable. Consider rolling a pair of dice. You only have a finite number of possible values that could come out of a roll. That makes this discrete. The idea of countable is similar. We can count the number of possible outcomes like we would count the outcomes in the dice example, except the number of outcomes could be infinite. Continuous data, on the other hand, is data that can possibly take on any value between any two numbers. As an example, consider measuring the amount of milk a cow produces. You could get a value like 2 liters or 3 liters, but it's also possible to get values like 2.37 liters, 2.819328555 liters, or even the square root of 5 liters. That makes this continuous data. Another way of classifying data is into 4 levels of measurement. We have the nominal level of measurement, ordinal level of measurement, interval level of measurement, and the ratio level of measurement. Each of these levels builds off of the previous level. Data at the nominal level. Data at the nominal level of measurement consists of names, labels, or categories. The data at this level cannot be arranged in any meaningful order. Consider polling people on the make and model of the car that they drive. You might order this data alphabetically, but this ordering tells us nothing interesting about the data. For example, we can't tell which make and model is the best car, the fastest car, etc. Data at the ordinal level can be measured and arranged in a meaningful way, but numerical differences cannot be determined or they are meaningless. A good example of data at the ordinal level is the grading scale used in most of our schools. If one student gets an A and another gets a B, we can certainly order these grades from best to worst. In other words, getting an A is better than getting a B. We can't, however, take the difference between A and B, and if we could, it really would be meaningless. Data at the interval level are the same as at the ordinal level, except differences can be found and are meaningful. With this level of data, however, there's no natural zero starting point. One example of interval level data could be people's birth years. Differences can tell us how much older one person is compared to another, but the year 0 was not the beginning of time. In other words, there were years before 0. Another example might be temperature. Since temperatures can go below 0, we think of this as being at the interval level of measurement, because differences can tell us something interesting, but 0 is not the natural 0 starting point for temperature. Data at the ratio level are the same as data at the interval level, except the data does have a natural 0 starting point. Consider the amount of gas you pay when you fill up your tank with gas. If you do not put in any gas, you pay $0, and it only goes up from there. So 0 is a natural 0 starting point. In other words, you cannot go below 0 in this example. These have been some different types of data and different classifications of data to consider as we move through the course.